স্টার্ট করে দাও সুদীদা।
So good evening.
Good evening, sir.
So what do you mean by correlation? I'm starting from correlation today. So what is the definition of correlation?
It is a degree of association between two variables.
Pardon once again.
Sir, it is the degree of association between two variables.
Degree of association between two variables. Fine. Any other modification of this definition? Or all of you agree with this definition?
Sir, I agree, actually.
Sir, I agree with the definition.
Sir, I agree too.
Any other suggestion regarding this definition? Anyone disagree? If I say this definition is wrong definition, then what is your reaction?
Sir, should we talk also about the fact that correlation does not mean causation?
No.
Sir, is it about linear relationship?
So linear relation between two
Yeah,
variables.
it is about the linear relationship between two variables. So not only the degree of relation, this is a degree of linear relationship between two variables. Correlation only tells us the linear relationship. Any kind of non-linear relationship is not determined by correlation coefficient or simply Pearson correlation coefficient. So what is correlation? Correlation is basically the linear degree of linear association, not non-linear association. Clear? So remember this point, because when you run some multivariate analysis, in every multivariate analysis, the correlation have a huge role. Say for example, factor analysis or cluster analysis. So in some multi-dimension scaling. So in that analysis, correlation have a huge importance. So, but remember one thing: this is a linear relationship between two variables. If it is more than two variables, then we are concerning with multiple correlation, or in some time we consider the partial correlation. I am not going to the details of the correlation formulas, etc. But I want to give you just basic idea of correlation. Suppose there is two variable. One is demand and another demand of a commodity, and another is price of a commodity. And the correlation between these two is minus 0.8. So what it means? What is the meaning of this statement?
Can you just
It's a
say
negative correlation.
I am telling that one variable is price of a commodity, another variable is demand for that particular commodity, and the correlation between these two variables is minus 0.8. So what it means?
So it means that there is a negative correlation and it is very strong. By negative correlation, we mean that it is inversely related. That is, if price increase, then demand falls, and vice versa. And by the fact that it is having a strong linear relationship, we mean that yes, most of the changes that is occurring with one can be explained by the other, or the deviation actually.
Can you explain most of the changes by one variable to the other variable with the help of
Most of the
correlation?
changes would be, I would be saying that would be wrong, but what I was trying to say is that most of the deviation,
Not maybe wrong, it is wrong. It is absolutely wrong. Why? Because think one thing, correlation only tells us the relationship.
yes sir.
What you willing to say that if one variable changes, how much the impact of other variable, correlation does not say anything about this. So if we want to find out the effect of change of one variable to other, in that case we have to perform the regression analysis. So basically, regression analysis gives us the concept of causal relationship between two variables or two or more variables. So what is the difference between correlation and regression? Correlation only gives us the idea about the relationship. Is there any relationship exist or not? If there is a relationship, positive or negative, then we want to find out what is the exact relationship. That means what is the causal relationship between two variables. If price increases by 1 unit, how much impact on demand? So in that case, we have to perform the regression analysis. So regression analysis basically gives us the opportunity to say something about the actual or the exact relationship between two variables, or basically the causal relationship between two variables. Now, if we consider a linear equation, suppose I write one linear equation. Is y equal to alpha plus beta x, and we write another equation plus e. So what is the difference between these two equations? These two equations are same or two equation is different? But if different, what is the difference between these two?
Sir, the
So the
second one
first
is
one is
Please.
yeah, go ahead, please.
so the first one is non-stochastic and the second one is stochastic.
First one is non-stochastic, second one is
Because
stochastic.
the error term is not included there, and the error term is included in the
Can you
second
say what
equation.
what do you mean by stochasticity?
So it means that it is having a probability distribution.
It is having a probability distribution. So what is the in first case you don't have a probability distribution.
No, like for a particular value of x, there's a single value of y. But for the second equation, for a particular value of x, there can be multiple values of y due to the presence of the term e.
Fine. So anyone any other argument? All of you go through the version told by your friend Anjana.
Yes, sir, it's absolutely.
So we can say this equation 1, this equation is a mathematical equation. This is a mathematical equation. This is a mathematical equation. Y equal to alpha plus beta x, or this is simply the mathematical equation used in for regression. But why we need this equation? This one. What is the problem with this? What is the problem with this equation? If we consider y plus alpha plus beta x as a regression equation, what is the problem? Or is there any problem for which we are considering this equation y equal to alpha plus beta x plus e, or what we call in generalized form epsilon? I am writing here e. Rightly pointed out, there is a problem of stochasticity problem or randomness. Both are used in simultaneously, and there is a concept of probability distribution also. But remember, in this case also there is probability distribution. But here we not use the epsilon. But when we use this term, this additional term epsilon, what is the difference between these two? Consider the simple equation of macroeconomics, we all know consumption is a function of income. We all know this, and we all know a prime y is lies between 0 and 1. We all know this. Now, suppose you collect some observation on C and on Y. Suppose consumption is 500 when income is 1000. 600 and so on. You collect observations, and with these two variables, you can perform a regression analysis like this, the linear form C equal to A plus BY. And what is our objective? To estimate this A and B. And we can use either this equation or this equation. But if we use equation 1, suppose this is equation 1 and this is equation 2. So one can use equation 1 or one can use equation 2. So if one student use equation 1 and another student use equation 2, is there any difference in between estimation of alpha and beta?
No, sir.
So these two equations have any difference?
Yes, sir.
But after estimation, alpha and beta is same. So why there is a difference?
So because in the second equation, we are also considering other factors which could affect the dependent variable.
So why not there is an effect on alpha and beta?
What?
Why not there is an effect on alpha and beta?
That is an assumption made that we make an
It's a little bit of confusion among you.
Sir,
Are you confused?
I have a question, sir.
Yeah.
Sir, how can we use that mathematical equation to estimate? Because in the method of OLS, what we basically
not?
do is
Why not in any standard book of statistics? If you're in your undergraduate
but-
syllabus also, you derive regression equation, use this particular equation.
but we used to, in the OLS method, if we consider, we used to minimize the error term. So proceeding with the second equation it will be more applicable to OLS. How could
So
we
if
proceed
we-
with the first
So
one?
if we write this equation, equation 1, and if we write this equation, so what is the difference? In both the cases, we are using the OLS method. In this case also, if we write this equation, then we also using the OLS. If we write this equation, then also we can write the equation method OLS. That's why we are getting same A or B. So then what is the difference between these two?
so the difference is only in the error term.
So, sir,
So I mean,
Carry on, please. You are very good.
sir, the difference is only in the error term. Essentially, what I'm trying to say is that if alpha means the alpha and beta coefficient remaining the same, everything remaining the same, we might see that what we are predicting to be the value of y, it's not coming out to be the value of y in actuality. So those deviations can only be possibly explained by this error term, and that is why we are taking the epsilon.
You
Yes,
are
sir.
right. Adarsh, you are right. But my point is, if we write this equation and if we write this equation, in both the cases we use OLS technique. Assume that we are both the cases we are adapting ordinary least square method to solve the alpha and beta. So in both the cases the techniques remain same. So if we don't write E and if we write E, it is make any sense?
So, sir, this can be explained in this way. So, the second equation is a better equation because, sir, am I audible?
Yes.
Yeah. The second equation is a better equation because on considering the error term, we are also taking into account of those variables for which the consumption is a function of. I mean, for the first equation, we are already considering income is the only function of income. Income is the only function of consumption. But in
Second
the
equation,
later,
you also considering the same thing.
but
In
we are also,
second equation, you also considering the same thing. Consumption is a function of income, nothing else.
but in the later case, we are also taking into account of those variables which are not necessarily included in the model, but has an impact on consumption by the error term.
You cannot got my point rightly. I am pointing out if we write E, listen, if you write this, if I write this epsilon, then we also using the OLS method. If we write this equation, then also using the OLS method, then what is the difference between these two? When we do you know what is OLS method? What is ordinary least square method? Do you have any idea what is OLS method?
Yes, sir.
So can you say what is OLS method?
Yes, sir. In OLS method, we minimize the sum of squares due to the error terms. So
So why there is a need for OLS method? Can you explain? Why while ordinary least square method or least square method is required?
sir, to obtain the estimates of the parameters such that the error is minimal. And error as in the difference between the real and the observed values.
Just a minute. Suppose these are two data points. So, or you consider your conventional notation xy. That is better for understanding. Suppose x is there, y is there. There is some observation. Correspondingly, here is some observation. What we do here, on the basis of this observation, what is our objective? To test the null hypothesis, alpha equal to 0, beta equal to 0 against the alternative, alpha not equal to 0 and beta not equal to 0. This is our objective. And since we are considering the linear equation, we are considering the linear system. So what we get? One is y1 is equal to alpha plus beta x1. Similarly, y2 alpha plus beta x2. Similarly, yn alpha plus beta xn. This is the system of equations, linear equation. So it is solvable or not? Is it solvable or not?
Yes, sir, it's solvable.
It's solvable. How can you solve this? How can you solve this? Any idea? Any idea? Do you have any idea how you solve this? Suppose this is the system, m linear equations with n unknowns. So if there exist m linear equations with n unknowns, the system of equation is solvable or not? What do you know from our mathematical background? For two unknown, 2 equation required. For 3 unknowns, 3 equation required. Similarly, for n unknowns, how many equation requires? N equation requires. So here, how many unknowns are only alpha and beta. And what are the number of equations? N equations. Is it solvable? Can you find a definite solution from this equation? Am I audible?
Yes, sir.
Can this system of equation is solvable? How many equations? N equations. What are the unknowns? 2 unknowns. So how you solve this equation? Is it solvable or not?
Yes, so it's solvable.
So we select any 2 equations and then solve for
Any
alpha.
2 equation.
Yes, sir.
It is possible to solve any 2 equation, then solve any other all other equations.
No, sir.
So who is arguing solvable? What is your method in your maths? Just think about the fundamental of mathematics. In class 7 or 8 level, what you taught? For solving equation, if unknown is there is 2 unknown, 2 equation is required. If 3 unknown is there, 3 equations is required. So for 2 unknowns, only 2 equations is required. But here we get n number of equations, just like this. This is a generalized version. This is the generalized version. So m linear equations with n unknown. Is it solvable? No, it is not solvable. So how we solve this? In that case, we create this particular expression EI. That is the error. What is error? Error is this minus B1. B1 is the coefficient of this particular equation. And term this as error in mathematics. This is in mathematics. So this is the error. And we try to optimize this error. Here optimization means minimization. And what is the rule of minimization? The rule of minimization is first order equal to 0 and second order is, what is the second order condition for minimization? Greater than 0. The second order condition is greater than 0. So we get these equations, all derivatives, first order derivatives equal to 0. If you consider the linear equation, so this is our linear equation. What we fit here? Y minus y hat. So y is this, and if we square and solve, then we get 2 normal equations. And after solving these 2 normal equations, we calculate 2 unknowns. That means to find out the 2 unknowns, we come with the help of mathematics in the form of 2 equations from n equations. See in this here, how many equations are there? M linear equations. So using this least square method, what is our objective? Why we use the least square method? Because we are not in a position to solve these systems of equation. Why? Because unknowns are 2 or 3, but number of equation is more. So it is not solvable. That's why we use this least square method. And with the help of least square method, then we come directly with these 2 equations. So 2 unknowns with 2 equations, it can be solvable. And with the help of these 2 equations, we solve the value of alpha and beta, or here A and B. Is it clear to all of you?
Yes, sir.
Yes, sir.
Why we use least square?
Yes, sir.
Is it clear? Or any query?
Yes, sir.
No, sir.
It's clear, sir.
It's clear? So when you're talking about these 2 equations, it's create little bits of confusion among you. What is that? Why you use these? Why you get same result? Because in both the cases we use the same method, least square method. But in first one, this is a deterministic model, rightly pointed out by someone. I think Anjana probably the name of that student. So this is the deterministic model. So this is the exact relation. But when in reality, there is no exact relation is there. Why? Because if we consider a matrix like this, suppose this is Y, C4, suppose with respect to 1000. Income level is this, suppose consumption is 500, one is 600, one is 700, one maybe 950. With respect to 2000 income, it may be 1000, it may be 1200, it may be 1700, it may be 1900. Individual have different consumption with respect to same level of income. So when we collect data with respect to this income level, someone collect this one, someone collect this one, and similarly for 3000, suppose it is 2000, suppose it is 500, is more, in that case it saves more. Suppose it is 1500, suppose it is 1600, and one take this one. So when we find this data, that means with respect to different income level, we collect one consumption level, not considering the all consumption level. So if we collect this one, that means my data set looks like now 1000, consumption is 600, 2000, that is 1700, here is 3000, now it is 500. Clear? So we are collecting the data randomly. Here we are collecting the data randomly. With respect to this particular variable, we are collecting this particular randomly. Or one can say, with respect to the given consumption level, there are different income level maybe there. One can consider like this. Consumption is 600. Here may be different income level. It may be 1000. It may be 2000. It may be 700. Whatever may be the income level. Clear?
Yes.
Yes, sir.
So if we consider
Yes.
this, in reality, we are considering this type of situation. And when we considering this type of situation, that means there is no longer an exact relationship between these two. But the relationship is a stochastic relationship. Why is stochastic? Why is random? Because with respect to given Y, we are collecting a definite C among the available all C. For with respect to the given income level, we are considering a consumption level among the available all consumption level. So that's why we are adding this epsilon or the stochastic term or the random term, or we call this as a error term. We call this as a error term. So why it is stochastic? Because we are collecting. Why it is random? Because we are collecting one among the all available consumption level with respect to given income level, or we are collecting a income level with respect to a given consumption level. We are collecting the data of a income level among the available income levels. Clear? It is. What is the meaning of epsilon and why it is called stochastic? Any query?
No, sir.
Now, do you think X is stochastic? Or Y is stochastic?
X is stochastic.
Y is stochastic?
Sir, X values are known, so how could X be stochastic?
So which one is stochastic? Y is stochastic?
So neither of them, sir.
Pardon?
Neither of them. Neither X nor Y. Because those values are known.
Why those values are known?
Sir, X is stochastic and Y, sorry, X is non-stochastic and Y stochastic.
Why?
So, because X values are fixed, but for Y there is an error term. Alpha plus beta X is the non-stochastic part, okay. But when we add the error term, it becomes a stochastic. So, in whole, Y is stochastic.
Yes. Fine. Thank you. So this part is a non-stochastic part. When we add this error, the stochastic term automatically implied y is also stochastic. This part is not a stochastic part. So basically what we did, with respect to given independent variable, we collect some dependent variable. And since epsilon is there, error is there. Why is this error? Because for exact x, there is no exact y. That's why this error. So if for given x, no exact y is there, error is there, that means y also stochastic, epsilon also stochastic. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So now first we consider the two variable simple linear regression and how we solve this in R. So you just write this comment. First to write attached cards. We are using the dataset names car, or you can write alternatively data cards, whatever be the whatever you wish. Write the first comment as attach cars. Run this. Then see the heads of car, how the data looks like. Here, two observations, one is speed and another is distance. So I am writing here the codes, not attaching the variable, attaching the data set rather. So if you wish to attach your data set, next write attach comment so that you can directly use the names of the variable in your different codes, or otherwise write codes like this: cars, dollar, speed. So first we willing to see the scatter plot, and here we use the function scatter dot smooth. What are the arguments? First is x variable, x is speed here, cars is the dataset name, speed is the variable name, y is the equal to cars dollar distance, and we write here the title of the graph. That is, this is the main is the title of the graph, dist tilde speed. So scatter dot moot is the function. Arguments are, these are the arguments: scatter smooth, scatter dot smooth, then first bracket x, assign x variable, assign y variable, and main is the title of the particular graph. If we run this, so this is the scatter plot. See, this is the scatter plot. More or less linear. Slightly non-linear nature is there, but we assume that this is a linear relation.
Sir, can you please show the comment?
This is the comment. Scatter dot smooth, then bracket, cars dollar speed. This one.
Sir, do we need to write this scatter dot smooth, this one in console?
No, in script.
Acha, acha.
Always you write in script, not in console.
Sir, X in caps or small?
In small, Y in small.
Okay.
All of you done this?
Yes.
Yes, sir.
Yes.
Yes, sir, done.
Now, to perform the linear regression model. What is the function? Function is lm. Remember this thing. lm is the function used for regression in R. lm is the function. So here we consider dist as dependent variable and speed as independent variable. So the style of writing code in R is first the function, then within bracket first write the dependent variable name, next the independent variable name. And if you attach, don't need to write the data equal to cars. If you don't attach the cars data, then write data equal to cars. And the object name here I given linear model. Clear? So when you perform the regression analysis, first is to draw the scatter plot to see is there any linear relationship exist or not. If exist, then go for regression, and the equation is, the command is lm is the function. Arguments are first write the dependent variable, use this tilde sign, and then the independent variable, and data equal to cars. If we run this, no error, so it's okay. Now we try to find out the summary of this model. Summary, the object name. Here I am writing linear model. You write your own name, what you given in the in place of object. So if we write here summary, so this is the output. This is the formula already given here. This is the residual statistics. Statistics regarding residuals. This is the coefficient table. And as we know, our rule of thumb is if p-value is less than 0.05, we reject null. So in regression, what is null hypothesis? Alpha equal to 0 and beta equal to 0 against the alternative alpha not equal to 0 and beta not equal to 0. So here both the intercept and speed, two variables are significant. Why? Because star is given. What is the meaning of star? Single star is 0.01, so it is less than 0.05, right? And one is triple star, that is 0.001. So both the intercept is alpha and beta. Here the coefficient of speed variable, both are significant. How you interpret this? Intercept is negative, right? Here. But what is the interpretation of this variable? If speed increases by 1 units, distance increases by 3.93 units. What is the R square? R square is 0.65. And what is adjusted R square? This is 0.64. That means 65% of the variability of dependent variable is explained by the independent variable. 65% of the variability of the dependent variable is explained by the independent variable. So the unexplained part is here 35%. And what is F? F is 0.89.57 and p value is 1.49. This, that means this also once again less than 0.05. That means F is here significant, that is overall model is a significant one. So when you write your analysis, first you write this starting from F. So this model is a overall significant model. Why? Because F statistics is significant. Then you write about R square and adjusted R square. That is 64% near about in terms of adjusted R square is explained by the independent variable, or 64% of the variability of dependent variable is explained by the independent variable. Then you come this equation, this model. So how we write the model of this equation? We can write this equation like this. This equal to minus 17.57 plus 3.3 speed. So this is the required equation, linear regression equation. .93. So another 3.93. We always write that variables that have significant effect. If the variable have no significant effect, we drop from our equation. So this is the final equation. And this is the values of alpha, this is the value of alpha, this is the value of beta. And both are significant. So it is clear to all of you?
Yes, sir.
Yes.
Yes.
Yes, sir.
So,
Do you have any doubt?
No,
So, sir.
No, sir, can you show the commands one more?
Command is lm within bracket dependent variable, name of the dependent variable and name of the independent variable, then comma, then data equal to cars. And you the name object name, give an object name. I am giving a linear model. You just like lm or whatever you wish. So the next question is this regression equation is valid equation or acceptable equation? The equation you solved, is this equation is acceptable equation? We accept this equation.
sir, accepted in the sense alpha and beta are significant from the p value. So
This
it
one is the
can
correct. This model is the correct model.
So intercept terms of the negative ratios. Alpha.
Just see your WhatsApp group. I am sending one data set. I've forgotten to send you before the class. So just take it in your laptop or any device so that we can move forward. And the thing is, the equation you solved, this equation is accepted if we consider the deterministic model. If we consider the deterministic model, then it is an accepted equation. But if we consider these observations or y is a stochastic variable, then this equation is not an accepted equation. Can you got my point? If we consider this as a deterministic model, then this equation is an accepted model. Accepted. Okay, fine. But if we consider the stochastic model, initial population model is a stochastic model, then this equation is not a accepted equation. Can you say why?
No, sir.
You will learn this in semester 5 syllabus, I know. You don't know the details of the econometrics, I know that. So I will try to give you the basic ideas of econometrics such that you know the codes today, and after knowing the entire details of the econometrics, you can easily conceptualize what is the meaning of today's class. So when we considering this model, y equal to alpha plus beta x plus epsilon, then regarding this error, we make some assumption. And before accepting the model, we have to check these assumptions. If the assumption is valid, all the assumptions satisfied, then our estimated model is a valid one. If there is any deviation in terms of assumption, if anyone fails, then we have to recheck, or we have to use another technique to solve the regression equation. And no longer this equation or the equation you estimated is a valid one. So the first is, what are the assumptions? Do you know anything about the assumptions of the linear model? Is this in your 4th semester syllabus?
So there is the assumption of homoscedasticity.
Is it covered in your syllabus, or you don't know that?
Yes, sir. We did the assumptions of CLRM.
Sir.
We did it.
You know that.
Yes, sir.
You know only the assumptions, not the details of the how to check this, how to, if there is an error, or if there is any violation in assumption, how to solve this, you don't know that, right?
No, sir. We did some of them. Like we solved the problem of homoscedasticity, and then we had tests for autocorrelation. We did
you
a
know
few
that?
of them. Yes, sir.
Fine.
Yes, sir.
So can you say what are the assumptions? First assumption,
Yes, sir. So the expectation of the error term will be 0.
what it means? So expectation of error is equal to 0. This is the first assumption.
Yes.
That is the mean of expected value of disturbance terms is 0. Clear? What is the second assumption? Second one is variance of epsilon. This variance of epsilon is constant, that is sigma square. The assumption is termed as homoscedasticity. If it is violated, then the problem of heteroscedasticity appears. What is number 3?
That it is not related or correlated with the X term.
That means not X terms. Covariance of epsilon I epsilon j is equal to 0. That is the problem of autocorrelations. Error terms are not correlated to each other.
Yes, sir.
Error terms are not correlated to each other.
And sir, neither with the explanatory variables, that is covariance xi.
I will come that point.
Yes, yes.
What is the number 4? Number 4 is
The
epsilon follows normal distribution.
Okay.
Epsilon follows normal distribution with mean 0 and variance sigma square. If there are any deviation, that means either assumption 1 or assumption 2 violates. And another one is 5 x is non-stochastic. That is, x is independent. These all are the assumptions regarding the error term. Another thing we have to consider when we try to perform the multiple regression, that is the concept of multicollinearity. It's another thing we have to consider. So we have to consider 5 assumptions regarding the epsilon or the error, and another thing is multicollinearity. Multicollinearity is no longer related to epsilon. I will discuss what is multicollinearity. So we have to check all these assumptions, and if we check all these assumptions and all the assumptions are satisfied, that is epsilon, expectation of epsilon equal to 0, variance of epsilon equal to sigma square, covariance between, that is no homoscedasticity is there, no autocorrelation is there, epsilon following normal, xi is a non-stochastic, xi is non-stochastic. This is by default we assume x is non-stochastic. I explained why x is non-stochastic, and second is, and the last one is a multicollinearity. So after checking all these, if all satisfied, then we accept the regression model or the estimated equation. Otherwise, we cannot be in a position to accept the regression model. Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
First, we show you. Just a minute. Find it. Sorry. We are considering these examples. This is a regression model. This is the example. Total fertility rate, TFR, female literacy, location of residence, and economic status. And this example is from the book of Shankar Kumar Bhaumik, Principle of Econometrics. I think all of you have this book. If not, then please collect this book. This is a very good book for an initial learner, not only the initial learner. This is a very good book by SKB sir. He is our sir in MSc, and I am given this example from the example of that book, Sats book. If you don't have this book, please buy this book. The name of the book is, I think, Principle of Econometrics by Shankar Kumar Bhomik. And this book is a manual for, basically the manual based on EView software, but you can use use the dataset for R also. That book is very good book. And what is the dataset? I'll show you the dataset first. This is the dataset. Clear? State-wise data, TFR, FLIT, location, and poverty. The book name is Principle of Econometrics by SKB, Shankar Kumar Bhomik. If you don't have this book, please buy this. If you willing to learn econometrics or do some work on econometrics. Do you have this book?
No, sir.
No, sir.
So you are so in your syllabus econometrics is there. So which book you follow?
Sir, we follow Damodar Gujarati.
Damodar Gujarati, I know. You just read this book. This is the Indian version of Damodar Gujarati.
Okay, sir.
In every case, the lucid explanation is there, and very good explanation is there. I think it is not in Calcutta University syllabus right now, but this book is very good book. So first, just see this. Don't try to write anything. I first explain the entire thing. Then I will show you the codes with the different data. I already give you the data. First, go through the process. So first, we run this model. You have to run first model in R. 1 second, for multiple regression also, the function is ln, right? And how we write the equation? Just with the help of the addition sign, plus sign. So first the dependent variable, then tilde, then first independent variable plus second independent variable plus third independent variable. And in this case, I use the dataset name as multiple regression, that is MLake. And see the summary of the model. First, we consider the summary. So what is the summary of the model? In this case, only FLIT is significant to estimate the total factor product. Location and poverty is not a significant one. And what is R square? Here is also R square, 65%. F value is significant. Overall model significance is there. Now, we check the diagnostic. That is, if this equation or the model is accepted or not. If there is any violation in assumption, then we have to fix that first, then rerun the model once again. So first we check the multicollinearity. To check the multicollinearity, we use the VIF function. The function is VIF, variance inflation factor. I will later on I will show you the detailing of this VIF concept. But in R, we use the VIF and then the object name. Here we are using, see, in R code we use the object name as model. So that's why we are using here VIF model. And to run the VIF, you have to call the library named car. So first call the library car, then run this VIF. And what is the rule of thumb? The rule of thumb is, if the value, any value of the independent variable is more than 2, then there is a problem. If all the values are less than 2, no questions of multicollinearity. This is the rule of thumb. If all the values are less than 2, no question of multicollinearity. If any one of the independent variable have more than 2 VIF, then you have to recheck the scenario and then once again run the regression model. So in this case, all the VIF values are less than 2. So there is no question of multicollinearity. So in between the independent variables, there is no multicollinearity. Next come the heteroscedasticity. For this, we use the library name is LM test. This is the library name, LM test. And we use here the BP test, that is the Buses-Pegan test, to check the heteroscedasticity. And what is the result? This is the result. So here, since p-value is more than 0.05, we do not reject null, that is homoscedasticity is there. In this particular test, the null hypothesis is homoscedasticity. So we are always willing the p-value more than 0.5. So here also no heteroscedasticity, homoscedasticity is there. Next we check the autocorrelation. And to check the autocorrelation, the library required is LM test. So library require LM test for autocorrelation or heteroscedasticity. For multicollinearity, the required library is CAR. So when you performing the regression analysis in R, so first call library CAR, then library LM test. At the initially, you just call this library, then you write this code. Otherwise, before performing this test, you have to call this library, then you can execute this test. So this is the library, and the command is, the function is DW test. It is the Darwin-Whitson test. This test is used to check the autocorrelation is there or not. And this is the value. Alternative hypothesis is true autocorrelation is greater than 0. So here we are accepting the null hypothesis. That means autocorrelation is 0. So no autocorrelation is there. Or another rule of thumb is here, if the DW value is near to 2, if the value is near to 2, you cannot get exactly 2, but if it is near to 2, from 1.5 to 2 or 2 to 2.2 or 2.3, then the answer is there is no autocorrelation. When you do your research, you can see if the value is near to 2, then the p-value is automatically more than 0.05. Clear? Next, you have to check the normality. There is normality of what? If error term following or the residuals following normality or not. For that purpose, we are using here quantile plot. You will already know what is the quantile not. And for regression purpose, you don't write the code we used previous day. You just plot the model. If you plot the model and hit in console, you get this graph. And see, all the points are nearly coincide with this particular line, except these two. So basically, we are considering, assuming that errors are following normality. So all the 5 assumptions here, satisfied. Then we can accept the model. So this model is a valid model. Why? All the assumptions are accepted here. So we can accept this model for our further analysis. So is it clear to all of you?
Yes, sir.
Yes, sir.
How you write this and how we explain this?
Yes, sir.
So is it clear? Or any doubt?
No, sir. It's clear.
So now you import the data I given in WhatsApp group. That is employee data.
Sir, I have a question.
Yes.
Sir, for the file type .sav, which option do we use from import dataset?
SPSS.
SPSS. Okay, sir.
The
Thank you.
SPSS file.
Yes, sir. Done.
Done, sir.
All of you input your data.
Done, sir.
Anyone have any problem?
No, sir.
Out of 40 or 45, only 2 responding.
Done, sir.
Remaining all others.
No problem, sir.
Done, sir. Done, sir.
Fine. Now see the structure. See the structure. See the structure? First is this is the table, not in a data frame. So if you try to do the further analysis, it is not possible with this particular form. So you have to make it as a data frame. Or in your data set, suppose large number of variables are there, you know which variable is required for your analysis. In that case, you make a subset of your data. There are different functions is there, Matute function is there in tidyverse. Actually in 5 days workshop, and it is not possible to show entire thing. I will just try to give you the basic concept of some all the things that you know. So if it is in table format, then you have to make it in a data frame format. So how we make it? First attach this, then we use this command. That is, we are transforming the variable like this. So we are defining y as a variable and make this new salary as a numeric variable. So first write this y, then s dot numeric, then salary. Y s dot numeric salary. If you write the names, of x, these are the variable names. So we are considering now y as numeric y, salary, x1 as dot numeric education, x2 as job category as x2, salary begin as x3, job time as x4, previous experience at x5, minority as x6. So first make this. Y, then assignment operator, assignment sign, then as dot numeric salary. Similarly, all others.
सर कोडটা একটু চ্যাট বক্সে দিয়ে দিলে সুবিধা হয়। Thank you.
স্যার এটা একটু আরেকবার বলবেন একটু উপর থেকে।
Which part?
স্যার ওই আমি স্যার এটা বুঝতে পারছি না যে ওখানে নেমস আমরা এক্স লিখছি, বাট আমাদের মানে ডেটা সেটের নাম তো আলাদা, মানে এক্স লিখছি কেন এখানে আমরা?
I am importing here X as. So if you import the data like this employee data, you have to write employee data.
তো মানে
Or you can
এখানে
change
আপনি
this.
নাম মানে নামটা চেঞ্জ করে এক্স করেছেন, অ্যাসাইন করেছেন।
Yes, yes, yes.
ওকে স্যার, থ্যাংক ইউ।
So it is not possible to write every time is a big name. That's why we make this at X. So when you import using import datasets function, you just write this line. X just write this. Automatically it defines as X. So you are assigning employee data as X.
স্যার নিচে একটু স্ক্রল ডাউন করুন। ঠিক আছে।
This code is given in chat box up to this, up to line 17, 11 to 17.
স্যার লাইন 9-এ ওটা কি লিখেছেন না?
Don't try to copy this. You just consider 11 to 17.
ও ঠিক আছে।
Then you make the data frame and name this as W. So W is now data dot frame with these variables y, x1, x2, x3, x4, x6. So in this way you can also make a subset of a full set. If your data consists 27 of variables and you need only 7 variables, you automatically make this data frame. So if we make this data frame, then our data only consists of these 7 variables. Object x3 is no, I am not running it here. Oh, x5, x6, w. So if you view w, see, this is your w. All are in x1, x2, x3, x4, x6. And you know what is the meaning of x1, x2, x3, x4, x5, and x6. Clear? Now, what is the second step? Second step is to draw the scatter plot. Same function, scatter smooth. X is your education, y is your salary. So if we plot this, see this. This is a relationship. Clearly, there is a non-linear relation in between salary and education. Clearly, there is a non-linear relation. Although we are try to feed it as a linear model, but scatter diagram does not display the linearity between these two. Similarly, for job category and this. Here, more or less, linear trend is there, but maximum value concentrate here and maximum value concentrate here. Next, we try to draw the scatter smooth for salary begin to salary. This is the relation. More or less, linearity is there. Similarly, the explanation for these two lines also. I mean, given the you just go to the chat box. Code is given there. So first we see the scatter diagram, and with the help of scatter diagram, we try to infer about the relationship between the variables. Now we try to calculate the correlation, and for this, two methods or two commands, two types of command is there are there. First, we use this core function. This is the core. So we make this W as data frame and use this NA or complete. That is, if there is missing value, it can calculate. That's why we use this particular form, NA or NA dot or complete, and we return the output in 2 decimal space. This is 2 digits, and in round form. So first we write round, then correlation. So if we don't write the round, then it automatically only gives the 2 digits, not round up. But it is, if we write the round here, then it returns the round up value. So what is the meaning of round up value? If the value is third decimal place, more than 5, it returns more additional of 1, or otherwise the same value. You all know. So if we click round, so this is the correlation between, this is a correlation matrix. But in this case, we don't have the significant level of the correlation. Correlation is there, but is the correlation is significant? No available information is here. So for that purpose, we use these particular codes, line number 28, 29, and 30. And you have to install the package HMISC. You have to install this package HMISC, and then you have to call the library HMISC. This is the library name. You just first install the package HMISC, H in uppercase, HMISC, and then call the library capital HMISC. All of you done this?
Yes, sir.
Are you able to install the package and call the library HMISC? Then call this library.
Sir, I'm getting something like the library does not means there is no package called HMISC.
You have to install this. Don't afraid after viewing this type of code, comment, error. This is a by default error of R. Ignore this. But if your library package is not installed in your system, you have to install it using install.packages or from tools.
Okay, so just 1 minute.
Yeah. All of you able to install the packages?
Yes, sir.
Done, sir.
Yes, sir.
Yes, sir.
Yes.
It's downloading, sir.
Yeah, do it.
Done, sir.
So all of you done?
Yes.
Then write this. Why? Because with the help of this package, we find the correlation, but before that we make it as matrix from data frame to matrix. So initially W is the data frame. See W data dot frame. So you make it first data frame, but to find out the correlation matrix with level of significance values, we make it first matrix. So Z S dot matrix W. And then the function is R core. The base function is only COR. But here the function is for HMISC package R core. R core of what? R core of J. That is the matrix, not the data frame. It derives the correlation value of a matrix. So make is add dot matrix W, then R core Z. And see. This is the value. These are the correlations and these are the p values. In maximum case it is 0. But see in case of Y and X4, it is 0.06. It is 0.06. If you see in case of X4 and X5, you just see this value for X4. It is more than 0.05. That is, we do not reject null. So there is no relation in between Y and X4. But all that other, there is a significant correlation with respect to the dependent variable. And if we see, for the timing, just ignore, only consider this. So among these 6 independent variables, we can easily drop this X4. Why? Because X4 have no significant relation with Y, because this p-value is more than 0.05. So we can drop X4 from our analysis. So first we drop X4 from our analysis on the basis of this p-value. See this line number 32. Here we use the same function lm. Y is the dependent variable, but what are the independent variables? X1, X2, X3, X5, X6. We drop the X4 and NA exclude of W. If there is any missing value, then exclude it and run this regression model. Right? We run this regression model. We run this. See the summary. X1, X2, X3, X5 have a significant impact, whereas X is not a significant variable for predicting the Y. So these three is significant. R square is very high, 83% explained. F is also, yesterday I told you, if F is high, that means clearly it is a overall significance is there, statistical significance is there. See, p value is this. It's very small. So we automatically say the model is overall fitted model. Right? So now, from this equation, it is clear X6 have no impact on Y. Then we rerun the model by dropping X6. Why? Because why do we run this? Because since X6 have no effect, we just drop this. So first we drop this X6 and run the final model. See the summary? All are significant. In the previous one, independent intercept terms is not significant. Now the intercept terms is significant. See, this is a point. That is in 10% level, but it is significant now. So there is a change, slight change. F value also increases. What is F? Explained by unexplained. So that means if we drop initially the explained part is 464. The ratio between explained by unexplained. Just remember the concept of ANOVA. What is the value of F? Mean square between by mean square error. So if denominator is less, automatically the value is higher. So F value increases means explained part increases, although the R square remains same. Clear? Now we check the VIF or the is there any multicollinearity? First we check the multicollinearity. Call the library car and run VIF and see what is the VIF value. Here the VIF value is less than 2 for X1, but more than 2 for X2, more than 3 for X3, more than 3 for X5. What is the how we calculate the VIF? What is the meaning of multicollinearity? Suppose in our example, Y is dependent variable. This is a function of this. If we consider X1 as a function of all other independent variables, and find out the R1 square. And then what is VIF? VIF is 1 by 1 minus R1 square. So what it means? Is there any relationship between X1 and all other independent variables? That is the meaning of multicollinearity. If the independent variables are correlated or not. If the independent variables are correlated, then the R square is high, and that implied VIF is more than 2. VIF is more than 2. So if VIF is more than 2, that implied there is a chance of multicollinearity. So in our case, in this case, VIF is 2 for these two. So what is the rule? The rule is here trial and error. We can drop any one of these two, either X2 or X3. Any one of these two. So here we drop the variable X3. So dropping, first we drop X3. Run this model. Comment is same. Summary of L1. See, R square is here 0.70. Initially, with both the variables, R square is 0.83. So R square decreases. So these three variables explain only 70% of the variability. F value also decreases. Now we drop x2 and included x3. So why? Because either x2 or x3 have some problem. So we first drop x3, consider x2 as the explanatory variable, and see the R square. Now we drop x2 and include x3 and run L2. And see, this value is 8015. So when we include x3 in our model, the explanation increases. So which one is better? X1 is better, x3 is better, or x2 is better? Clearly x3 is better than x2. Why? Because explanation increases, F value increases. So we consider this is a appropriate model, not the previous one. Now we check the VIF of this L2 model. Check the VIF, all three are less than 2. So there is a side relief, no multi-collinearity is there. Now we have to check another assumptions regarding epsilon. Finally, we establish the model after checking the multi-collinearity. Next, we check, is there any heteroscedasticity? Is there any autocorrelation? So how we check this? First, we check install the library LM test. Also, the library Ju. If Ju is not available to you, just click the library LM test. And we run the comment BP test L2. L2 is the model. To run this, now the problem arises. See here, the p-value is less than 0.05. The p-value is less than 0.05. So clearly, homoelasticity is not there. Homoelasticity is not there. So we run a model, we fit a model, but this model is not free from heteroscedasticity. The model has some heteroscedastic error. In this class, I will not discuss how to check, how to solve. That you learn in next semester on when you in PG, how to solve this. Weight test this technique is there, how to solve this, and etc. etc. I just give you the real situation when you work. If you got this type of result, then your regression equation is not a good one. Now, if we test the autocorrelation, so DW test of the entire model, you can write the model name or like this equation. See, DW test also insignificant, 0.03289. That means we are accepting, we are rejecting null. So rejecting null means 2 autocorrelation is greater than 0. So this model have autocorrelation problem as well as heteroscedasticity problem. So this model have autocorrelation problem. See, this is the value of 1.83, near to 2. But if it is more than 1.9 or something, I think it is more than 0.05. So then we can conclude that the model is free from autocorrelation. So here the model consists of autocorrelation, the model consists of heteroscedasticity. Both the error is there. You can find this with the help of Ju package. This is another function, Darwin-Whitson test, and this is the F value. See, this is the DW statistics. This is your autocorrelation value 0.08. Yeah, this is a lag 1. So alternative hypothesis is rho not equal to 0. Rho equal to 0. You have the alternative hypothesis. And what is p value? More than 0.05. So you do not reject null. That is rho not equal to 0. This also, the DW statistics same. You just see 1.83, here is 1.83. This is the conventional technique used that in textbook, and this is the using lag 1 row statistics, that is DWH statistics. Rho is nothing but 1 minus, I think, h by 2 rather, d by 2. As I remember, I cannot properly remember that formula. So if this situation happen, then you have to check why heteroscedasticity is there, why autocorrelation is there, what is the order of autocorrelation, and then you have to remove the heteroscedasticity, make it a homoscedastic model. You have to remove the autocorrelation pre-model, and then rerun the regression model to check. After checking all the assumptions, and then your model is a good fitted model. So that's why in statistics or in econometrics, regression is the most toughest model. And when you run a regression, be cautious that your model is free from any error or not. In real life situation, when you do your real life data, in 90% case, the data is not free from heteroscedasticity. So be aware of that, check all these, and for today or in this workshop, this is the material I will provide to you. I am not going to the details of how to check, how to correct the model, how to set it up from heteroscedastic to homoscedastic, and I'm not showing right now to this. And that is in your 5th semester syllabus, you know this. If time permits, if any other workshop, if we meet again, then I will discuss the later part. So up to this part, do you have any problem or not? Do you understand the scenario, the situation?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Any problem up to this part?
No, sir.
No, sir.
No, sir.
No, sir.
In future, when you write your research paper, or when you try to publish your paper on somewhere, my suggestion is try to avoid regression. If you run regression, then after knowing properly the methodology, you can run regression.
Okay, sir.
And if you see the good journals, in good journals, if you see in maximum papers, they use regression and they write the entire model, and then they revalidate with the correction they made in terms of weighted least square or in terms of any other autocorrelation error. They are writing this. If you it is available in Google, I think. If you go through the papers on regression, so that published in good journal. If it is not in good journal, only regression is there, no error, no checking is there. That also published. But be aware of that. As a student of economics, try to follow the rules, follow the assumptions, check this. If it is all satisfied, then your model is a good one. Otherwise, your model is a biased model. All of you write the codes. I am given this in chat box. Any query up to this part on regression?
No, sir.
No, sir.
No, sir.
So,
After this workshop, do you able to run your own analysis?
Yes, sir.
I need some practice, sir.
Absolutely. Practice is
Constant practice is needed.
rigorous practice, not the constant practice.
Means we need to do that. Means constant means
Yeah, yeah.
regularly.
Actually, the thing is, if you don't practice, you cannot remember the codes.
Yeah, we will forget it. Means there are many libraries and there are many
Yeah.
codes.
So you have to once in a week you run all codes. Then you have to remember. All codes is given to you. You know all codes. Data is given to you. You just practice all this. Try to create new data set from the different books. In Gujarati book, there are different example is there. You just create your own data set, write the code. In this way, you can practice with the given data set, not the arbitrary data set or the unknown data set. You just copied it from any textbook. Then you practice. Then it is easier to relate the software with the book. This is the way. Then it is you can be familiar with the software. So the last topic of this workshop, the simple optimization problem. Because in economics we are starting with the optimization. I am showing the simple LP problem, how to solve this. So for this you have to import the library that is LP solve. You have to install packages, use the code install.packages, and then import the library LP solve. Then actually this is the problem where we try to optimize a equation with two variables. Suppose the objective function is 5x plus 7y. Here the objective function is 5x plus 7y. So in objective function, we write the coefficients. What is the objective function? Objective function is suppose z equal to 5x plus 7y. Subject to the constant. What are the constant? X less than equals to 16 into x3y less than equal to 19. 2x plus 3y less than equal to 19, and last one is x plus y less than equal to 8. X plus y less than equal to 8. This is the function problem. So if you use the equality sign, no worry, you can write the equality sign also. So this is a simple LP problem. How we solve this in R? You can first you have to set the objective function, only the coefficient. Then you have to make a matrix for the coefficient of constants. So from here we make the matrix. What is the matrix? 1 0 2 3 1 1. This is the matrix. So we write this matrix here. Matrix C 1 0 2 3. This n row is 3, number of row is 3, and by row 2. If you don't write by row 2, then the matrix form like other way. These are not the row elements. Next we sign the inequality signs. That is all here less than equal to type. If it is greater than equal to, just changes in greater than equal to. And then we set the right hand side constant. It is right RHS are the vector C 16, 19, and 8. This is the final optimization function. So what we done here, we try to optimize, we try to maximize. So that's why we write here maximum. Then the objective function, that is F object, then the constant function, then the direction function, then the right hand side. So if we run this one by one, see, so this is a successfully run and the objective value is 46. If we write here Z, assign this, run this, then summary of Z. You can see everything is there. Direction, objective, how many constants are there, everything is given here. This is a simple illustration of the optimization. I will give this entire code in chat box such that you will able to do this in future. You just copy and paste after calling the library lpsolve. If we write the solution of this, it gives you the solution of the two optimal variables. The value of x is 5, the value of y is 3. I'm not going to the discuss the sensitivity or dual variable, etc., etc. It's a simple illustration. In this way, you can use any optimization problem in R. You can solve any problem. Say it is portfolio optimization or it is asset optimization, whatever you will, you can do it in R. So any doubt, any query?
No, sir.
So thank you for listening me for last week, for about 1 week, bothering me. So wishing you a very great future. Go ahead. So thank you all.
একটু ওয়েট করো, প্রিন্সিপাল স্যারকে রিকোয়েস্ট করছি জয়েন করতে।
So before that, one thing I request you, Is it possible to please open your camera, and I want to see everyone, because before last 7 days I was teaching you, but I cannot see your face. So it is possible to please one by one unmute and open your on your video and say something about the workshop in 1 or 2 lines. If it is possible for you. Please unmute.
Hello, sir.
Hello, sir.
So please say one or two sentences about the experience of workshop.
Yeah.
So what is your experience?
Sir, it was a very, how to put it?
It's a very informative session, informative
Engaging.
workshop.
However, for me personally, it was a bit tough because all concepts are new right now. Still, I am actually was not very good with econometrics, so it took me some time to understand what was going on and everything. Uh, and I'm going to also later on watch the recordings and going to see other videos on YouTube about this to understand the whole thing. And I hope I will be able to make something out of it as well after this. So thank you very much, sir, for giving us the head start.
Thank you.
Thank you very much.
Good evening, sir. This is Shamrat, and the session was really informative. We learned new concepts, and since we are dealing with econometrics, and also in our further semester we have the applied econometrics, so this was kind of a start, as Adarsha mentioned. It was kind of a start, and this can also help in our further if we take up research. So, like sir mentioned, regression is going to be a very important part for honor analysis. So, thank you, sir, once again. And if possible, maybe sir could organize some more webinars on this. Because what I felt like the regression part could have been more illustrated. And overall, it was a nice experience, and the session was really informative. Thank you, sir.
So thank you all of you. You are the representative of the entire batch. So
Thank
usually
you,
this is the starting
Sudipta.
point.
We have our principal sir with us, Dr. Tilak Chatterjee sir. So
Good evening,
the,
sir.
Good
the
evening.
workshop is ending today officially. So all of you will get a link for the feedback form in your mail. Right. It's not possible to be given in the chat box since many of you haven't joined today, as well as few have left in between. So it will be given in your mail, and from there on you will get the certificate. So I would request our principal sir to formally end this workshop. Sir,
Just a minute. Am I audible?
Yes, sir. Yes.
Yes, sir.
Am I audible?
yes, sir.
Yes, sir.
You are.
Okay. This is the problem of being in this position. So many phone comes in between. I have interrupted 2 phones just to join this session. Well, this is the final moments of this webinar. Formally, I thank Sudeep for being here for the last 7 days and apprise the students and train the students about our software and its application in economics. Thank you, Shudip,
Thank you,
from
sir.
from my personal behalf, as well as from Bunkim Shardar College and the Department of IQAC and the Department of Economics and the IQAC. All these are formal words. Most informally,
So your mic is off.
no, one phone is coming time and again. Okay, so informally, I'm very happy that students conglomerated in this place together to gain some knowledge and maybe some um, working experience as well. In the days to come, they will find it useful as and when they would apply all these skills in any sort of work which requires much more application. Those who are taking applied econometrics will be benefited more, or later during the post graduation, students who will be getting into much more research work or project work will find it to be useful. On that day, everybody will remember Shudip, and that is the real thank you. When they will remember you, that is the real thank you.
Absolutely, sir.
Yes. Um, I have received a proposal from some of the teachers in Kolkata to organize a similar workshop for the teachers. When the numbers will be large, I'll get in touch with you, or Nilendu will get in touch with you. So now you have taught the students. Now you will be teaching the teachers of those students. So that is the one of the most significant outcome of your exercise for this last few days. Now coming to the students, you will be giving a feedback, and the feedback is an electronic feedback. So আমি নিজে বিশ্বাস করি যে ফিডব্যাকটা কখনো এরকম ইলেকট্রনিক ফিডব্যাকে হয় না। It is better that some of you should speak here. এই মুহূর্তে হয়তো 34-35 স্টুডেন্টস আছে, তো তাদের মধ্যে যদি দুজনও কেউ কথা বলো সেটা খুব ভালো হয়। আমি কাউকে বলবো না তুমি বলো বা তুমি বলো, এরকম কিছু বলবো না। জাস্ট আ মিনিট। My 80-year-old mother has blown the shankho for concluding this important workshop. Anyway, from the students, any one or two students, please say something. ভালো না লাগলে বলো ভালো লাগেনি. That is of course necessary for Shudip da also, Shudip sir also. That is also necessary. আর ভালো লাগলে বলো ভালো
Your
লাগে.
feedback is always enrich us.
Absolutely, feedback should be much more critical. যেটা ভালো লাগেনি বলবে ভালো লাগেনি, আর তাহলে কি হবে নেক্সট টাইম অর্গানাইজ করার
We can modify ourselves.
Absolutely. So I want any two students, undergraduate or postgraduate, কারণ এখানে বোধহয় বেশ কিছু পোস্টগ্রাজুয়েট স্টুডেন্টও ছিল।
Yes, sir.
Any two students, please speak from your heart. সম্রাট সাধুকা।
Yes, sir.
বলো।
Yes, sir. Am I audible, sir?
Yes, you are audible.
Yes, sir. So, like I mentioned, the session was really good. And what I particularly liked about Sudeep sir was, sir taught the theory well. So, when he discussed the regarding the R script, how to perform a regression or how to do the autocorrelation test, he initially did the theory first. So that is something which is deliberately neglected in any workshop. I did few workshops on Excel previously, but this was something which I liked about Sudeep sir, that he went through the theory and then we got an idea. We were learning econometrics in semester 4, but since he revisited the entire theory, so it was a good thing. And also we understood each and every concepts well. Particularly day 1 to 3 was really well, and regarding day 4, day 5, it went well. But I found, like I mentioned previously also, the regression thing could have been more stretched. Rest is fine. Rest is fine, sir. I liked it overall. It is good. Thank you, sir.
Anybody? Samrat, good feedback.
Thank
Well
you, sir.
thought feedback.
Thank you.
আর অন্য কেউ?
Sir, am I audible?
Yes, you are audible.
Yes, Bhaskar.
Just give your introduction.
Sir, I am Bhaskar Das from Surendranath College. So, basically, before this workshop, I had a dilemma whether I will be taking up applied econometrics in fifth sem as a DSC paper or not. But after attending this workshop, I really have confirmed that I will be taking this one because I liked the way sir spoke. The way sir explained, I think if this was not done, I would not have been able to decide whether I would have decide. I would have decided to take this paper in this sem.
Okay. So this is also another output. Not the process, it's the output.
Output.
It's somebody taking a decision. Good. Recently I have purchased a car, but I don't know driving. I want some Sudeep-like person who will be helping me to drive the car so that the dilemma gets out from myself. Anyway, that was a joke. দুজন ফিডব্যাক দিল, আর যদি কেউ ফিডব্যাক না দাও তাহলে ফর্মালি
I am requesting anyone female candidate.
Yeah, আমি অ্যাকচুয়ালি জেন্ডার আলাদা স্পেসিফিক করতে চাইনি, বাট এনিওয়ে এটা আমি জাস্ট একটু আগে ভাবছিলাম। তো সামবডি ফ্রম দি আদার সাইড।
Hello, sir.
Introduction, please.
Sir, my name is Purnami Mondol and I'm from Vidyasagar College for Women. And it is a very knowledge enriching workshop because we don't know about the various concept of the regressions, and we just deduct some of the important informations about that, and Sudeep sir just clearly elaborate the whole thing, and the our programming concepts are so much clear to us, and this is very good that we are the students of advanced econometrics are very lucky to have Sudeep sir, and if there is another workshop on it, we will eager to join it. So thank you, sir.
Okay. So from short run to long run.
Yes.
Okay, we will be thinking on it. We'll be thinking on it because Sudeepের কোনো end নেই. Anybody else?
Sir, am I audible?
Yes.
Sir, my name is Binayak Datta and I am from Vijayagad Jyotish Rai College. And
Okay.
I have just finished my 6th semester this year. And especially I found this workshop very enriching because I will be going into PG and I think these concepts will be very helpful for me in my next phase of my education life. And the way Sudeep sir has explained everything, I especially like the part where he took one whole day to explain the statistical inference part, because my statistical concepts were not that great because I did not have statistics in my past paper, and whatever I did in my economics, I found some places were lagging, but the way he explained it has made the concepts very clear. And even I feel that if this workshop can be done once again, and I would love to join then also. Thank you.
So what I suggest, Nilendu, don't break this group, okay? In this stage of
Okay, sir.
pandemic, we being getting locked inside a room, most of the students not keeping in touch with each other or the faculty, really আমরা খুবই বিচ্ছিন্ন হয়ে আছি, but a very creditable job being done by Nilendu and of course supported by me from my college. We have brought almost more than 60 to 65% students of economics honors of the first of the presently the third semester and the fifth semester, earlier also the outgoing sixth semester. তিনটে ইয়ারেরই সমস্ত স্টুডেন্টসকে আমরা এই হোয়াটসঅ্যাপ গ্রুপে পৃথক পৃথকভাবে রাখতে পেরেছি। আবার যখন ফার্স্ট ইয়ার অ্যাডমিশন নেবে তারাও থাকবে। আমরা we always tell them that keep in touch through this WhatsApp group. It does not cost anything. It's just responding to whatever messages being sent by Nilendu or also by me. এই আর ওয়ার্কশপের হয়তো আমি অতটা অ্যাক্টিভলি কোথাও থাকিনি বা পার্টিসিপেট করিনি, because Nilendu, Bappaditto, Devopriya, all they were doing all these things. But in general, these WhatsApp group are really working well with us. Keep in touch. Amra shotti tomader kauke chini na, but you see, Nilendu is providing so much of benefit for you. And on 3rd and 4th, Kaushik Gupta sir will be delivering a workshop on international trade, 2 days. Then on 4th, 5th, 6th there will be, আমি এটা এখনো ঘোষণা করিনি, এখন ফর্মালি ঘোষণা করছি না, কিছুক্ষণ পরে পাঠিয়ে দেবো। এন্ট্রান্স মাস্টার্স এন্ট্রান্সের জন্য 3 দিনের ওয়ার্কশপ হবে, ডে লং। জানি না কতজন জয়েন করতে পারবে, বিকজ ইটস আ ডে লং ওয়ার্কশপ, 3 দিন ধরে হবে মাস্টার্স এন্ট্রান্স নিয়ে। And then there will be a series of workshop on Indian webinars on Indian economics, মোস্টলি আমি করব বা অন্যান্য স্যার ম্যাডামরাও থাকবেন। সো ইউ সি, আমরা কেউ কাউকে তোমাদের চিনি না, তোমরা সবাই আমাদের সন্তানের মতন, চিনিই না, কিন্তু তোমরাও চেনো না আমাদেরকে। কালকেই আমাকে একটি মেয়ে ফোন করে বললো, স্যার আমি আপনার সঙ্গে মাঝে মাঝেই কথা বলি, আপনি আমায় এত হেল্প করেন, কিন্তু আপনি কে ভাবো। সো উই আর কিপিং ইন টাচ উইথ ইউ থ্রু দিস হোয়াটসঅ্যাপ গ্রুপ। রিয়েলি মানে আমাদের মানে আমাদের গ্র্যান্ডফাদার, ফাদার, এরা তো কেউ কিছু এসব দেখেই যাননি। ইটস আ মানে আউটস্ট্যান্ডিং ওয়ে অফ কিপিং ইন টাচ উইথ ইচ আদার। তোমাদের এই ওয়ার্কশপ যখন ভালো লেগেছে, আই উড সাজেস্ট নীলেন্দু, ডোন্ট ডিসকন্টিনিউ দিস গ্রুপ। আমি জানি কেউ ইন্টারেস্টেড থাকে, কেউ থাকে না। যারা ইন্টারেস্টেড নেই তারা চলে যাবে, কিন্তু যারা ইন্টারেস্টেড থাকবে তারা এখানে স্টে ব্যাক করো। We will definitely be organizing much more useful workshop, jeta from where you can move forward from where you are now after the end of this workshop. I promise that such workshop will be held in future too, and Shudeep too has become a member of this family. I would ask Shudeep not to leave this group, so
No,
that
sir, no, sir.
students, if
I
they
am
have
always here.
so you remain here, and you see this group of about 40 members, a family of 40 members will continue. Workshop হয়তো down the line after 3 months or 4 months, যখন তোমাদের টাইম হবে, যখন ওনার টাইম হবে, তখন করা যাবে, ডেফিনেটলি করা যাবে, বাট কিপ ইন টাচ। সো ইফ ইউ কিপ ইন টাচ, ইফ ইউ কিপ দ্য প্রমিস। আবার তোমরা যেমন ফিডব্যাক দিচ্ছ ভালো লেগেছে, এমন হতেই পারে যে কারোর এইটা ভালো লাগেনি। কেন? তার জন্য সুদীপের ওয়ার্কশপ দায়ী নয়, হয়তো তার ইকোনমেট্রিক্সই ভালো লাগছে না, হয়তো তার ওই ম্যাথামেটিক্যাল বেন্ট অফ মাইন্ডটাই, মানে স্ট্যাটিস্টিক্যাল বেন্ট অফ মাইন্ডটাই নেই, নাই থাকতে পারে, সেটা যে খুব দোষের তাও নয়। সো সাম উইল বি দেয়ার, সাম উইল নট বি হিয়ার, and maybe somebody else will be joining, so the group will continue. Shudeep, Nilendu and me, we will be here, and definitely we'll come out with much more Olympic in the months to come. Olympic তো থামে না, সেরকম এটাও থামবে না। Thank you, Shudeep. Thank you, Nilendu, who has done the
Thank you,
entire
sir.
hard work.
Thank you, sir.
Thank you, Bappaditto, who has come across all the technical problem shooting. Devopriya initially took a very prominent role, accumulating all your registration fees, etc., and building the database. So everybody has given their best effort from my college, except me. আমি এই ওয়ার্কশপটাতে যে খুব ইনভলভ ছিলাম তা নয়, বা এই ওয়েবিনারটাতে যে, ওয়েবিনার তো নয়, এটা ওয়ার্কশপই, এটাতে যে আমি খুব ইনভলভ ছিলাম তা নয়। আসলে প্রিন্সিপাল হওয়ার এক আনন্দ যেমন আছে, ব্যথাও আছে।
So actually, this is the admission time. It is not possible for you to join this. I also the bursar of my college.
হ্যাঁ, আমি
I am
কথাটা
facing the
বলার
same
আগে
problem.
কালকে আমি রাত্রি 9:30 বাড়িতে ফিরেছি। আজকে রবিবার, সারাদিনে বাড়ির লোকের কারোর দিকে তাকাইনি পর্যন্ত, এই চলছে।
In between this workshop, I also say one day that I will take your class from 4:30. I have another assignment, but somehow that was cancelled. That I will take on 4 p.m.
ইয়েস। সো যাই হোক, সুদীপ বুঝতে পেরেছে কেন আমি এখানে থাকতে পারিনি। এনিওয়ে, আমি তোমাদের সবাইকে প্রমিস করলাম, তোমরা যারা চাইছো বা তোমরা আগামী দিনে যারা চাইবে, তোমাদের জন্য এই ওয়ার্কশপ আবার হবে, নিশ্চয়ই হবে। থ্যাংক ইউ ওয়ান্স অ্যাগেন, থ্যাংক ইউ নীলেন্দু, অ্যান্ড থ্যাংক ইউ অল দি পার্টিসিপেন্টস।
Thank you all.
ভালো থাকো।
Please everyone check your mail. The link for feedback form has been sent. Thank you. Thank you.
Got it, sir.